It seems I'm live. So, as you currently can see, you can see nothing because I have become black because there's nothing to see, of course. So, I'm gonna change that real quickly. No. Here. Hello. Here. Hello. I'm in my usual outfit, as you can see. Lab coat and all. And today we are gonna program, I am going to program coding problems, 100 of them. This is gonna suck, isn't it? And because nobody is gonna see this, or nobody will see this, so I can say whatever I want. Nice. Anyways, without further ado, let's fucking begin. Yes, but before you listen to me just talking for multiple hours or so, I might turn on some music. Yes. Then this is gonna be a pain, isn't it? So sorting. Okay. Currently there are some technical difficulties, it seems. So it's gonna take a bit. Anyway, use that time to make yourself at home, I guess. And we're gonna see how quickly I can resolve such things. Okay. A good start. Wonderful. Then because it's going to be easier that way. Wonderful. Wonderful. Okay, it seems I'm back. Why does it have to be this shit? Anyways, gotta find my life split again. Where did I put it? Why doesn't it automatically create a place where I can find it? It would be so much easier. Gonna turn on the technical difficulty screen, I guess. Oh, I was muted. Okay, it works. Good enough for me. Yeah, speedrun! I like the energy of the chat. I'm gonna fucking kill myself. Anyways, so I'm gonna turn some music on and you can tell me how shit it sounds. So too loud? Too quiet? How is it? Give me some feedback, please. Well, nothing happens instantly. Okay, sound good. That is okay for my standards, I guess. So, now it's time to fucking finally start with the speedrun. So, I'm mostly gonna ignore... Okay, well, I'm not gonna ignore chat because there isn't any chat really, but I'm gonna focus up a bit, I guess. So, how does the speedrun even work? I should explain before I start. Basically, there are those things called daily coding problems, and I have over 100 of them. And I just paste in the problem into my cool editor named Thonny here. And then I'm gonna solve them. And with solve, I mean I'm gonna ignore edge cases because edge cases are shit. And I don't care about edge cases. And when I solve them, and I think, okay, that was difficult, I'm gonna explain my solution to chat. Then I'm stopping timer, explaining the solution, and start when I see the next problem. Okay? And you need to trust me about the fact that I haven't seen the problems before. And if you don't trust me, fuck you. And if you don't agree with my rules, also fuck you. So, so time to start, I guess. The first one. That is the problem. I'm gonna toggle it to comments. Oh shit, I should have started. Yes. Quite professional, I know. Alright. Now, given a list of numbers, I hope it is readable. It should be. You must be pretty blind to not be able to read this, so gotta be alright. At k of 17, you should return 10 plus 7. Okay. Basically, find all the pairs that make up a certain number. Gotta call that 1. And we're gonna take those example, alright. L for list. You want a list. Nah, already used name. Gotta take L then. Sometimes you need to take a L to win ahead. Go ahead. I'm gonna kill myself. So, first you go through the array. In one pass. That means I need to look at the terms. Gonna brute force it, I guess. Oh, nice music. So. Python, writing big, I guess. Again. So, gonna try out if it works. With A and 17. I should print it out if I want to see it. Ah yes, I can't run a script before I save it. I should have prepared more, but anyways, whatever. Not like I will care. BCP 001. Comparison, of course. True, okay. Then I'm gonna put in 16 because there can no two numbers be added so that it turns out 16. Okay, and wanna do another case. 15 plus 7 is 22. So this should put out true. Wonderful. And with that, I think it counts as solved. I don't think I need to explain that one, it was quite easy. So next. I was pretty fucking slow, but I hope I speed up with time. Too long. Like my dick. But only an idiot would say something like that, so I won't say it. So, give an array, return a new array such that elements of I don't expect the one that I expected would be output. Well, the easy way is just using brute force again, and that would be quite bad. But I'm gonna do it anyways because there is no exceptions that I can't use that. So DCP2, and it gets inputted a list and an index. But output would be, and now I can just do this one. Turn. I'm gonna make a new list. And what you're gonna see now is absolutely horrible coding practice, so don't do it like this, but it will work, and that is fine enough for me. So you're gonna assign that, gonna give it a new member, and then the new member is the product of the original list but without the I. That means we're gonna take it from the first element to the ith element and concatenate that with the ith element till the end. I'm gonna think one double point should be enough for that. Now, does the function prod exist? I don't fucking know, so I'm gonna find out right now, I guess. DCP02 of the or example 1, 2, 3, 4, 5 with the so save it so I can run it. Of course it's not defined. Then if I'm gonna do it the hard way, I can do it. Or I just define the prod. Because I'm lazy and I'm not gonna check for something like bad inputs or something like that, because there are no bad inputs. If you input something bad, it's your fault the program crashes, honestly. So don't blame the program for it. Assign it the start value times the ith element and return this. Oh, I should. At least my code has no bugs, so that is good, I guess. And here you can see I fucked up. Maybe changing one of those indices might work. That wasn't the right one. Wonderful. And another example to test if it really works. Fuck. Oh, it works. I just can't read. I'm stupid. Wonderful. Solved by my standards. Next one. Also, I don't think I need to explain this one, because wasn't that ununderstandable, I guess. Oh, shit. Fuck. So, again, comment out. Okay. Root to a binary tree, implement serialized roots, would serialize the tree into a string, and deserialize would deserialize the string back into a tree. Okay. Then I'm gonna copy that. Good. This should work. And I should make a deserializing function. I'm gonna do it right here. First the serialize of a node should print the tree as a string. I think the easiest way to go about it is, because it's a binary tree, I know if something is on the third layer, the second layer must be full. So I'm first gonna print out layers, then left to right, then next layer, left to right, then next layer, left to right. So I'm gonna do basically a with first search, I guess. Yes. Well, gonna work out anyway. Oh, I'm not gonna use for because it's binary. Stupid me. String is that. With a node dot. Okay, so it can be used. So then I'm gonna initialize that with node value. Yes, cause the values are all strings, it's gonna work out. Of node dot left. So, cause there's the case that the node doesn't have any children. So only check if it has children, or reciprocally quit the function if it doesn't have any children. And print out a return, good. And because if it has a left child, if it has a right child, it automatically has a left. I don't need to check for that before, so I can check that later. Okay. And that should basically be it, if I'm not stupid. But I am stupid, so it's probably not. So I'm gonna check it quickly. Serialize the node. Oh, I should print it out. Would be pretty nice. Root left, left, left dot right. Oh, I should also bring in how is it called? Trennzeichen, but I forgot how it's called in English. But yeah, I should do that. What should I use as splitting? Yeah, I'm just not allowing users to use a semicolon, a colon as string, as character in their strings. So yes, everything is correct. So time for deserializing. deserializing should make a tree from the string. So string s. And we can format our string to be a bit more comfortable by making it... Okay, it's gonna be fine this way. So is s.split at or splitting character. Wonderful. Then we have a list of split node names first. And the rest we can also do by recursion. But we must be careful this time so it works out. Yes, that's a thing I didn't think about. I just noticed I can't just make one of those, that would be not enough. So if, because then a left leg might be confused, the left leg of the left leg might be confused with the right side, and that would be pretty bad. So, oh, I accidentally did that first search. How do I change that? I'm not going to be able to use recursion. How did with first search go again? Because nobody said I can't use... it's called breadth first search, of course. Okay. So... there surely is an easier way to do this in a binary tree. Because also modify this, but that would be pretty horrendous. That's how it is. We need to establish a queue, and while the queue is not empty, so we need to fill the queue first with those two. Assuming they exist, of course. Okay, but we can check for that in the queue itself. So we're gonna take the first element of the queue if it isn't empty, and first we check if it is a none object. Then if it isn't, we can check its value and append that to the string with the splitting char again. Dot 0 dot value, and now we append to the queue the children of that one. Nice. And does this work if it's empty? Then if it's a none, we add just a breaking character. Okay, I hope that works. Can only find out by running it. Hello? It should print that alright. Q isn't empty. Doesn't print anything. That's bad. Oh, it's because the queue never empties, because I really should check if it's a none or not. And add that. Oh, wrong button. Misinput. None. And if it's right, it's not none. Like I said earlier, you can just put the if for right in the if for left, because it can't have a right child if it doesn't have a left. Okay. It's just I need to be careful about the else's now. If there isn't any, it shouldn't be outputted. Two times, because we are skipping over two children. Okay. Why doesn't it work? Time for some debugging, yay! Yeah, stop. Oh, I should also delete the ones I already worked off. Nice. But it shouldn't output two of them. Output this. Then it checks if the next one, the right, is none. It isn't, so it output this. Checks for the children. And because the left one doesn't have a right child, it outputs this too early. What if I don't do this at all? It's the original that is. In this case it should be okay. What if I'm going to append something at the right side? call it right dot left. Yes, there should be another splitting character. Because it doesn't have a right one. It doesn't get added in, so it should not. Maybe I can do it right here, and that would work. No. So. Again, too much, because it just happens at the parents level, and that isn't correct. Maybe I can do it this way, so the right one gets added anyways if it has a left one, and then it triggers the else case. Correct. What if I don't have one at all? No, that's wrong. There should be... I can also do this. Okay. That would work. It would create some extra stuff, but that isn't of concern. So I can work with that. The root is that. And here I think I can use recursion, right? No, I can't. Sadly. I'm gonna use the same thing again. Left, right, left, left, right, left, right. Maybe I can use a scheme of binary counting or something like that. Would be overly complicated though. I can do another queue to see what is currently in queue to become to have children's. And I remember the current index. And that I can do by just using a for loop, which returns if the queue is empty. No. But I don't know till what I'm counting, so I know till what I'm counting. I'm an idiot. Of course I am. With the length of the list itself. And I start with queue number 1. If the queue is empty, you don't need to bother. Yes. You can break the loop. I can break my fucking leg. Yes, and if it isn't empty, I'm gonna take the first element and of the current element, the list we are looking at is... we should start with 1, because we already had the 0th element. If the current one is looking good, then we should... when it's not equal to this, then we can append to the 0th element on the left a node that has its name. Else. And if it has a left child, we might also check if it has a right child. Oh, my neck. Give it the right. Okay. Then it really should be more like a while loop, because I'm gonna sometimes jump over multiple. Yes, while that is in range. Good. Okay. And in that case, we also append the queue by this newly created left one. And here we also append the queue by the newly created right node. Wonderful. Yes. And overall, here we let I jump 2 times. If it hasn't, we let I just... Well, we're gonna let I jump either way, because we checked both. So we can also jump 2. Nice. Another thing I need to be concerned over... Not really. Have a left, okay. Ah yes, in the case this is empty. Oh, it's automatically assigned none, so it should be alright. I'm gonna test out that first. Break. Yes, return root. We can check out if it serializes that right by serializing it, deserializing it, and serializing again to look if it still has the right shape. And because all those functions are deterministic, it shouldn't matter how often we serialize and deserialize it. Ah yes, and of course. Okay, that did the right thing, I'm just stupid. Oh, I should first check if I+1 is even in the length. If not, there is no need to check, I guess. No, and I should write correctly. Oh, 4 viewers. Impressive. Hi to the new viewers. I'm not gonna introduce myself. That would be very cringe. I should assign the index. Okay. That is something. It is wrong, but it is something. So, how did I mess up? I assigned the root, then assigned left and right. First of all, let's look at the splitted thing. Left, right, nothing, nothing. Right, left, nothing, nothing. That is left, left, that is left, right, right, left. Right, right, and this are the children of them? Should be alright. Then, well, this in this range. Q is not empty. 1. This is not empty. So we create the left node. That should be this one. Zero dot left. I should also check for the value to see that it's actually called. Yes, the left one gets appended. It's the left node. Oh, of course. I'm an idiot. What should I say? I forgot to delete the first element from a queue. Okay. And if we delete that, I'm fucking impressed that it worked alright. Now, what was the test we are gonna make? This one. Comment that out. And if we're gonna deserialize it and see again, and we wanna check if that is that. And just put it under so we can see it better. Oh, of course, because I modified the node. Fuck. So. Gonna put that down. Yippee! It fucking worked, finally. As you of course can see, the code is really simple, so what should I explain about it? I mean, come on, it's just a bit, well. But I would pause for a moment, just so I can really explain it a bit more. Basically, your serialize function here does basically your standard breadth first search. It makes a queue of the nodes we haven't checked yet, which in our starting case are the left and the right node. And every time, and we start by checking the first element of this list, if it is none or if it is something. In that case, if it is actually something, then we append it to our string and append their children to the new queue, so we can later check if they have children and so on and so on. If it is none, or what might happen if I queued on a child here that doesn't really exist, then we just make another splitting character, so later in the deserialize function we knew there should have been a child but there isn't, and left and right trees don't get confused if there is a big empty spot in between, to explain it visually. So, and lastly we delete the first element, so the queue basically moves forward and the next element is the first. And in the deserializing function we basically do that, but in the other direction, and use the splitting characters we used there to separate the left from the right tree. And because if you have a tree, here's the camera, you start with 1 point that goes to 2, and they go possibly to 4, but they might be possibly missing one from the left arm, or in the case of the camera, this is the left arm here. and we wouldn't be able to differentiate members of the right arm and the left arm if we didn't fill up in the in-betweens with those characters. Yes. That was a short and rather shitty explanation, but it should be good enough, and it's all you deserve. So, going to move on. I didn't want to do that. Next one. I should hurry up. Oh shit, this is a long one. Okay, that wasn't a problem. I just confused my emails. Good that this wasn't a problem. Okay, toggle comment. But if I go on with the same speed, I'm not gonna make 100 in fucking 2 days. Gonna need multiple years for that shit. So, given an array of integers, find the missing positive integers. In other words, find the lowest positive integer that not exist and can contain duplicates and negative numbers as well. For example, should give 2, should give that. Linear time and constant space. DCP 3. No, it was already number 4. We can already save that, so it runs quicker when I need it to. It gets inputted in a list. First of all, that. Just threading the testing, because I know I'm gonna need that one. 3,4, -1, 1. Should give 2. Positive integer that does not exist in the array. Yes, we're gonna put our basically minimum we're trying to find. I'm just gonna count it low and assume it is 0 because assume it is 1 because it is the lowest positive integer. And now we're gonna run it over the array and check if there are... Oh, I should of course use a big integer to compare it with. I'm just gonna use this one. And we're gonna run it through the array. Oh. I actually have an idea. Or do I? Not really. In-place manipulation. And with linear time. This is going to be hard. I can find the difference and add it up. We should ignore negative inputs. So we're gonna go through the array and ignore all the negative inputs. And then subtract we subtract a number every time. brain fog. For example, if we have 3.4 minus 1.1 and subtract, for example, 3, we assume this is the lowest. We assume the lowest missing integer is 2. 1 from it. 1. We ignore that one. And this goes to minus 1, so we know it isn't the lowest. Yeah, of course. In that case, I'm just gonna set that to minus infinity, because we don't care about it. And in this case, we know it is the lowest because 0 is missing from this list. And 0 is the lowest positive number missing from this list. In that case... Quite difficult, this one. Gotta think about it real hard. Why am I so stupid? The simplest option would be just going over the array again and again and counting upwards integers, but that wouldn't necessarily be linear time. Is it? If I delete the number I already counted, then I land on 2. I'm gonna count up. Like I said, this is gonna be a hard one. The simplest solution would be just to sort the list and count, but can't do that. I maybe have a solution, but we need constant space for it. How gonna do that. Write down the next smallest. Well, I want to do basically a checklist and then delete all the one we already saw and just take the minimum of that. That should all require just linear time, but that isn't constant space. How can I project a checklist on our input array? Can do some devious little tricks, but that wouldn't be so fitting. Can I use the indices? If I use that. Third indice. First of all, we can notice that a number, there must be one smallest integer, a positive integer that isn't in the list if the list is shorter than the highest integer in it. That's right. If we use that to our advantage, can we use it to our advantage? Go out. Look where it is, assign that this. Next one, look what it is, assign that to this. That goes. Assign them nothing. And you can notice that there is one element missing, and it's the second element. Use probably n. That wouldn't be good. What can I use? Permutations? Not really. gonna swap that one. Actually, that is a way to go about it. We can use our input array to basically make a checklist. And if something is there, we must mark it with a 0 or something like that. And if something isn't, we can mark it with a 1. How do you implement that? Range L, and basically the ith element points to the -1's place. We wouldn't want to destroy it. So this is gonna show back. For example, we have that one. Then we have a cycle. And both are basically confirmed. We can switch them. Yes, then go for the next element and swap them. Go for the next element and swap them. But if we do swapping, this might take quadratic time. Third element should be assigned 1 cause it's existed. Should be also multiplied by 1 cause it exists. Okay. Maybe I can deal with that by checking if this element is then our current element. That's one. Basically, like third element is this one. Is that bigger than 3? It isn't. I think that if it is bigger than our current element, then we don't really care about it. This might be a bit complicated. This is gonna take a while. That much to the 100 coding problems. I'm not even gonna reach 5. Maybe a sip of water will help. Nice. Nobody other than the 4 viewers are gonna stay. I mean, what you're doing. Cause clearly this isn't very interesting. Well, if you have an idea how to solve this problem, a little help from the chat would be appreciated. Because who said I couldn't cheat with my own rules? Maybe this will work. that case, we do the old switcheroo, but a bit different. Gonna remember this. Reassign this, then assign this with their value. How would that change our list? One gets assigned to here. Third element would be assigned with, should be assigned with 3. Ah yes, that I forgot. If it isn't, then we just override it. My programming socks really ain't helping this problem. It's too hard, just like me. Well, our current element is 3. 3 minus 1 is 2. The second element is this one. And we assign our current element to this one. But because this is so... Oh, of course I should also check if it's negative, because if it's negative we don't care. If there isn't anything to replace it with, make it 0. Set it to 0. Yes. So, nice. But it should work regardless of what I do. Okay, that is alright. If I do this one, sure. Okay. Ooh. Ah yes, we should of course check if... Oh, cool. List manipulation is even possible. Yeah, I'm gonna do it first. If a list element is bigger than the length of our list, then only set our current element 0. Else. Okay. Does it work? Nice. Do the other things still work? What if I do it this way? Seems to work alright. But I'm not really sure if that counts, because this is just convoluted. So I probably need to test this properly. Okay. Because the last step in the function would be to go over it and say the lowest missing. So go over it again. And if your current element is 0 or negative for any reason, I don't know why that would happen, but maybe. It would even be enough for it to be lower than 1. For it to be lower than your current index. Plus 1. For it to not count. Turn your length of the list plus 1. What did I fuck up? Much is equal to your so. Okay, that would work. But we need to output this. Now this should work. If we add another 3. If we add a 2. That is a problem indeed. Why? Now it skips over that one. No. Why can't it just work? Okay, what happens? Our third element points to the 2. Or 2 is smaller than... It's enough if it is smaller than that one for us to care. But our 4 also exists. The 4 points to -1. It gets overridden by the 4. By the 2. And that's why it's bad. That's why we switch when it isn't time for it yet. Yes. To have a better understanding of what is actually happening, I'm gonna print out that. So, of course. Okay. Third element replaces the 2. Because it replaced the 2. Placed, assuming the second would be placed there by eliminating this problem. would be pretty backtracking like, and we don't want that. What if we embrace the backtracking nature of this problem? It should terminate at maximum n because we just have n numbers. But how can we be sure we catch them all? Remember where we left off. In that case, we could have maximum going a cycle and then doing the rest. That would be linear time. Nice. How do I do that? Just gonna comment out this because maybe we can use it. Current index is out with 0, of course. While the current index is smaller than the length of L. Can it be equal? No, it shouldn't be. So index then the length of it, and then set this element equal to 0, and move on. Else we have something interesting to do. It is enough if it's bigger equal. No, we are searching for positive integers, so it isn't. In any case, we increase the current index by 1, so we can move on. Else, we have index that is smaller, so we can do the jumping inside the array. So we're gonna take the array at the position current index and going position -1. Yes, and if that is within our bounds, bigger than 0, we move forward. First of all, what if it is smaller to equal to 0? Then we're just gonna assign that one. And move on. Else our current index should be reassigned to what they have here. And I assign it to that. And I need to assign that one to that. So I need to remember that one, so that would have been correct. Okay, got it. And if I'm done jumping around in indices, I need to move on. Because we can also go back to our minimum indice, for which we know that everything before that we already checked. Current index gets to be our minimum index. Okay, and the same for this. And we win if our minimum index gets far enough. Ah yes, we should also not get stuck in an infinite loop of one element pointing at itself. So, where do we do that? We check if it isn't smaller than 0. And if it isn't bigger than itself. If it's bigger than itself. So it doesn't get stuck. Okay, what is going wrong? Where did I mess up again? What is our minimum index? What is our current index? 0, our current index is 2. Mine's at 2. Our current index is L of 2. Minus 1 is the first element. And is it greater equal? L of our current index. Why doesn't this check here work? What am I not seeing right now? Greater or equal? So we should land here. it does that. I accidentally reassign minimum indices somewhere, or why doesn't it go up? Oh, of course. It obviously also isn't supposed to happen, but at least better than what we have going on before. So, our current indice. And our minimum indice would be of interest. So we start by getting this down to 2. Of course, that would be thrown off. Then, okay. Where's the 2 gone? Okay, it was remembered. That or current can be overwritten. Okay, our current is 2 points to 4. Our 4 isn't greater than that, so it's okay. Just in case. Okay. Now this points to an element that at -1 is smaller than 1. Maybe I should do it this way. Cause I preference them too hard. Now I confused myself. Back. So the first element is empty. Then this should be replaced with a 2, but it points to something that goes to that. So we want that element to be replaced by the 4, but also our current element replaced by our current indice. Good. Of course, our current element of indice -1. Because that's how we are dragging this around with us. Ah yes, this way. There. Does that? No, that isn't right. Ah, that's why I'm so careful. If it points to something, then really shouldn't be able to do this. But that would create a problem again. Don't need that anymore. And that should work. And that doesn't work. Fuck. Special treatment, yeah. Because I can't understand my own code anymore. So we know. Index is 0. We leave that be and only increase our current index by 1. Now, does the case from earlier still work? Yes. No. What happens here? 1 points to this. If your current index is bigger than L, it doesn't happen. If this is smaller or equal to your current index, case we have 5 and the element is 1. Like 4. Bigger than 0. I confused me too much. We are gonna put this on hold because I already wasted 1 hour on this or something like that, and gonna move on. Okay. Well, this one. No, dropping viewers. No. Not my viewers. Come back. Anyways, we have this implementation. Untoggle it. Can turn the first last element of power counts returns implement car and CDR. Sounds like a pain to me, but alright. Already setting up the testing. 3.4. CDR of comms of 3.4. Okay. Now defining the car of it returns you that. So you have as input that thing here. And that seems to be a function, I guess. So function would be something like you have as input two numbers and return please the first one, and you should return p of this f. I'm gonna name it G, so it's... Oh, I name it F for first. And similar for the other one. CDR. Last. Gonna save it. Oh, of course I should. Yay! Easy. And for another example, let's put this to 5 and this to 2. And this to 3 and 9, just so we know it works every time. It does! Wow, that was fucking easy for... compared to that one before. Ah, long problem again. Like my... Oops. That wasn't my intention. So, XOR linked list and more memory efficient, and a doubly linked list. Instead of each node holding next, it holds a field named both. It's an XOR of the previous and the next. Implement X has an add element and gets an element to the end, and get index which returns the node at the index. There's no pointers, you can assume you have access to get pointer and dereference pointer functions. Well, this is Python, so need to use that one. How can I test if it works? Let's just assume. So, what is XOR linked? That means if you have two integers, like and yeah, something like that, then your output would be 0, 0, 1, 0, 0, 0, 0, 1. How do I get out the original? The next in the previous field. Okay, that first element in the list clearly knows that it's the first. List. And it would be pretty practical to have a first element, so how do you define classes again? Here. Just gotta take this, yoink, here. don't need that shit. Just need previous, next. Or shorten it because that already exists. Yes. By previous node. But we actually don't save that, we save both. And that is the XOR. How do you do XOR in Python? I don't know. So I'm gonna search for it. So bitwise operation. There is no one. So here, copied from the net, so it definitely must work. And to check that it actually does work, I'm gonna test it on our examples. XOR of I'm dying. No, I need to save it before I can run it, of course. It doesn't work. So that should make it bitwise. Yippee! If I, for example, add a 1 and 0 and add a 1 here, still works. Fine by me. Oh, I should leave it in. If it in any case doesn't work. Yes. And P. We start with nothing, so this is our first element, and we should remember that one. Okay. Of course we need our items for the list as a separate class, because it would be too easy if we could just do it this way. And here we actually have the value and previous and the next. And by standard, both are null. And I assume previous and next are gonna be the addresses of the elements. That should work. So we're gonna not without it. And for initializing, this will be the first. Now to the fun part, the actual functions. We want add element, and to add that element we must go to the currently last element. How do we do that? We assign a current, and at the start the current one is first, if I write it correctly, that is. So the current element will be the element's previous dot both will only consists of its previous element, because we add the element so it doesn't have a next one, and the current element shouldn't have an element noticed as next one, so both only holds its previous element. Just to make sure this actually is true. And we can abuse it by now holding its previous and the additional elements pointers. Moving on, the current element gets reassigned to be the additional element. Good. That should be all. And get index. Then we probably have to do a loop for more while index is bigger than 0. We of course always decrement the index by 1 in each loop. And we move forward by making ourselves a iterator, basically, that currently points to the first element, and it moves along by remembering. Yes, we need also to remember the previous, so we can subtract it basically from the XOR. Self dot first dot both, because both only contains the next. And as we move through, it's gonna be the first both. So that one then it's more like a next. Should be next. Next should be the iterations both, but doing something with it with n, so only the next pointer and not the previous pointer is saved in it. So let's assume you could gather stuff out from it again by adding it again, or XORing it bitwise again. This should output this one. I'm just gonna write it this way. Oh. Wonderful, I was correct, because I am so overly smart. So yeah. We need to remember the previous one. That is the next one. By calculating the previous one. Before we assign over it, previous gets assigned that, and the next will be that without the previous. So can even ignore this one. So we have both minus the previous. Previous is the iterator's current one, and is both next and the previous. No, then I really need the previous one. Both. That's not gonna work. If I moved it along. Okay. Does this work? Previous is the current. The current gets assigned to the next one. And the next one is the currents both XORed with the previous. Yes, that should work. If in any case the current's iterant is none, then return none. Else, if it's all said and done, return the current iterant. So, I don't know if I can debug that because it uses pointer-like code, and that may be a bit finicky. I can try it, I guess. Xlist shall be an XOR list with an item with value and nothing else, yes. And yes, that is all. First, Okay. It's the same element, good. Get at 0. 0 additional arguments were given. Oh, Python. Of course I need to include that. Good, that works. Does it also work if I add an element? Yes. For type item. Yes, there's the problem. Maybe the internet knew something about pointers. Yes. Maybe so. No. Well, that isn't Python. I can use that. But first of all, to get a look what that ID function actually does. Certainly not the same. Get maybe I can work with that ID crew. But I need the be able to get the object from the ID. Yes, it's equivalent. Okay, nice. Well, basically the code works if you are able to dereference the ID to the object itself. But as that is not possible in Python, I can only assume this code works. I mean, it's simple enough that it should work, so... Well... I need to... And with that said, I probably need to stop for today, because First of all, I'm fucking tired. Second of all, I'm hungry. And third of all, nobody seems to care, so can I end the stream, I guess. But the problem number 4 is still haunting me. So overall, in this 2-hour session or more, I only did like fucking 5 coding problems, where most of them were easy. I am ashamed of myself. So it's time to go black again. And maybe I'll stream another day, maybe not. We'll see, we're going to see. So, bye. I'm slowly going to... Ah, there is it. Bye bye.